electricity and then used waste heat from the generator to heat your house, you'd be doing cogeneration. Unfortunately, you'd have to run the heat all summer or not use electricity in the summer to make the idea environmentally and economically sound. Cogeneration can provide tremendous energy savings, but there are 3 conditions to be met: location, location, and where it is too.
Much of the real estate that you see in this picture is being heated by the building I'm standing on. This is the University of Toronto, and this is the Central Power Plant building. 6 kilometers of tunnels connect most of the downtown campus to the building. Much of the heat distribution is done by steam, some by hot water. In any event, the water in the hot water system is also heated by steam from the main system. On the average, during the winter, the campus requires the generation of 250,000 pounds per hour of steam. During the summer months, the steam demand falls to a low of about 30,000 pounds per hour. In the central power plant, large natural gas-fired boilers provide the steam. Steam generated by boiling water collects overhead in steam drums and is fed to a main steam header. From the header, it's off to the tunnels. As it happens, the central power plant also distributes electricity to the various buildings. This fact, coupled with the need for at least 30,000 pounds per hour of steam year-round, makes the central power plant an ideal site for cogeneration. Cogen is the simultaneous generation of electricity and heat from the same thingy. Generating electricity from natural gas is efficient, but it causes a lot of extra heat. If you're in a position to use that heat for something, the idea becomes extremely efficient. The university chose a gas turbine generation device that can produce up to 7 million watts of electricity and 30 to 90,000 pounds per hour of steam in the process. The lower steam generation figure matches their summer minimum steam load. The gas turbine is much like a jet engine, except that it burns natural gas and doesn't have to fly, so it can be made more robust for continuous operation. You'll note that the unit is in a sound-deadening enclosure under negative air pressure. The turbine operates at about 11,000 RPM. A gearbox reduces this speed to match the operating speed of the generator. The generator supplies close to 20% of the campus's electrical needs. So far, we've put natural gas in and we're getting electricity out. The other side of the cogen equation is to capture and use the turbine's heat. Attached to the hot end of the turbine is a duct burner. Here, the turbine's hot combustion gases are mixed with natural gas again to boost the exhaust temperature another 600 degrees or so. This conflagration heats water in the attached boiler. In the boiler, the turbine exhaust gives most of its heat to the boiler water, turning it to steam. Before going up the chimney, the exhaust also passes a boiler economizer. The economizer preheats the water going into the boiler. Finally, the exhaust passes another heat exchanger that preheats the water that flows in the university's hot water heating loop. After as much heat as possible is squeezed from the exhaust, it's sent up the building's 300-foot stack. The cogen unit requires some additional support equipment. This large compressor raises the pressure of the incoming natural gas from about 30 to about 300 pounds per square inch, required by the turbine. The gas compressor requires cooling. The university decided on a closed-loop glycol system, similar to a car's cooling system but bigger. This is a water purification plant for a water injection system that helps control emissions from the turbine. Control room equipment allows for synchronization of the generator with the hydro grid and monitors the turbine for vibration and its operating temperatures. The total power consumed by all of this ancillary equipment is approximately 5% of the generator's output. If you're just boning up on cogen terminology, this 5% is called the parasitic load. In a nice twist of fate, the cogen unit occupies the area of the plant that used to accommodate large coal bins for the boilers. The boilers were converted to natural gas years ago. As a bit of a lesson on how we as a society generate and distribute electrical power, remember that this unit is only here because it saves money through more efficient use of resources. Most public utility power plants can't make use of the waste heat they generate. At the last turn of the century, all electricity in our province was generated by independently owned small electric plants. It will be interesting to see where we are at the next turn of the century. I discovered this one by accident. Rather than wasting soap, water, and energy on some old thing you want to clean up, stick it in the laundry tub for a week. The repeated wash and rinse is like going through a car wash. To make this work, I invented a flow restrictor on the drain that allows the tub to back up a few inches of water. Be careful with this idea.